So here we have the XY table. But here is different. In the last lesson, I gave you both sets of numbers. Here, I only give you the X numbers, but instead of giving you the Y numbers, I give you a rule. And this rule is telling us is that Y is equal to X minus 3. Now don't get too scared about that. This rule just tells you how to calculate what Y is. You see, actually, the Y variable, the Y numbers, they actually depend on the X numbers. You could say that they are dependent on the X numbers. We're going to learn about dependent, we call it dependent variables later, but it just means it depends on it because the only way you can figure out what Y is to calculate it based on X. So what is the rule here? The rule is that Y is equal to X minus 3. So in terms of math, you would say that the Y values that go here are just going to be equal to whatever the X values are, and you subtract away 3. So this rule, Y is equal to X minus 3, in terms of math, this is what you would write. In terms of words, this is what you would write. Now, why do we do this? Because now we have enough information to find out what these numbers are, and then we can plot them as we did before. So what happens here, if for this point, the X value, just forget about everything else, the X value is 3. We take this 3 and we stick it in there. The Y value is going to be whatever the X value is minus 3. But here, X is equal to 3. We put it in here. 3 minus 3. What is 3 minus 3? It's just 0. So the Y value is 0. So now we've calculated our first point. 3 for X and Y for 0. You could say, in terms of a point, 3, 0. That's the first point that we've calculated. Now we have to do it for all of the other points. So we stick 5 in here. We take whatever X is, which is 5. What's 5 minus 3? 5 minus 3 is 2, and that's what Y is equal to. So we put a 2, and now that's telling us is that Y is equal to 2. Let's do it for this number. 7. X is 7. 7 goes in here. 7 minus 3. What is 7 minus 3? That's 4, and that is equal to what Y is. So we put a 4 down there. All right. Now X is 8. We stick 8 in there. What is 8 minus 3? 8 minus 3 is just 5, and that is 5 is equal to now what Y is equal to. Y is equal to then 5. Finally, X is 9. Put 9 in there. What's 9 minus 3? 9 minus 3 is 6, and that value of 6 is now what Y is equal to. So you see, now we have all of the points that we need to plot the graph, which is what we did in the last lesson, but we had one extra step. We actually now had the X values given to us, and then we had to calculate the Y values based on a rule. This rule was really simple. Just take the value of X and subtract 3. Those are going to be the Y values. So we say that the Y values are dependent on the X values. Remember that word dependent, because we talk about it a lot more later. Y depends on X because we are calculating Y based on what X is. Now we can take these values and we can plot them and see what it actually looks like, because I don't know about you, but when I look at numbers like this, I don't know what it looks like. So now we're going to figure that out. X is 3, Y is 0. 3, 0. Remember, the X direction is here and the Y direction is here. So when X is 3, it's right here, and Y is 0 means I don't go up at all. Y is 0, so that means there's a dot right here. That's our first point, 3, 0. Our next point, 5, 2, you can write it in terms of a point with parentheses and a comma. You can write it like this, or we have it in the table. 5, 2, X is 5, Y is 2. X is 5, and then you go up, Y is 1, 2. So it's 5, 2. There's a point then right there. Next point, 7, 4. X is 7, Y is 4. X is 7, Y is 1, 2, 3, 4. Means there's a point right there. Next, 8, 5. X is 8, Y is 5. X is 8, Y is 1, 2, 3, 5. Means there's a point right here. 9, 6. X is 9, Y is 6. X is 9, Y is 1, 2, 3, 4, 5, 6, which is right here. Now I think you can all see that this forms a beautiful line. Let's just connect the dots just to make sure. We'll be line it all up. Maybe see if we can get to go through all of these points, and we try it. And we see that we can connect that line to go right through all of these points. Now, in the last lesson, we talked about what could this mean, that kind of thing. We can talk about things all day, but this could represent, for instance, in a rod, these numbers here on x are the distance from the end of the rod. 1 centimeter over, 2 centimeters over, 3 centimeters, 4, 5, 6, 10 centimeters from the end of the rod. And going up here could be the number of insects I'm finding on the rod. So there's no insects at the end. There's no insects 1 centimeter. There's no insects 2 centimeters. There's nothing here. And at 3, there's a value of also 0 insects, right? But at 5 centimeters, I have 2 insects. At 7 centimeters, I have 4 insects right here, and so on. And it's telling you that the insects are going up, 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 starting at 3 centimeters over and going up the same amount each time. So what I like to do is take this down. We have several more of these, but remember the concept is the same. We have to calculate the y values because they depend on the x values, and then we just plot them and see what the picture looks like in terms of the graph. All right, here's our next problem. We are given the x values, 4, 6, 8, 10, and 12. We do not know the y values, but we are given a rule. Y, whatever they are, is just going to be equal to 2 times x minus 6. So this one is a little more complicated. We are given, if you want to write it in terms of math, that the y values in this column is 2 times x. So you put a 2, little dot, x, 2 times x, minus 6. And so after you multiply this, you have to subtract 6 away. This is a little more complicated than in the previous one. So the way it works is, whatever numbers go here, we just take 2 times x, and then whatever we get from that, we subtract 6. So the easiest way to do it is just to come right in here, right next to the table. And let's say it's asking us to take a look at 2 times x, but in this case, x is 4, right? And then whatever we get, we have to subtract 6. So we have 2 times x minus 6. Now, we just calculate. 2 times 4 is what? 8. And then we still have to subtract 6. Don't forget, we still have to do that. What is 8 minus 6? 2. So what we have figured out is that the number that actually goes in here is 2. 2 times this minus 6. Then we get a y value of 2 because the variable y is equal to 2 times x minus 6. We say that y depends on x. And so that's what we call it dependent. All right? Next, let's take a look at the next one. 2 times x minus 6. So 2 times x, but x is this, 6. Then we subtract 6. What is 2 times 6? It's just 12. We still have to subtract 6. 12 minus 6? 6. So the answer that we get is 6, and that is the number that goes in there, 6. All right, next. We have to take 2 times whatever x is, 8, minus 6. What is 2 times 8? That's 16. Still have to subtract 6. 16 minus 6, 10. And so this is a value of 10 right there. All right, next we have, let me just double check myself. Next, we have 2 times whatever x is. 2 times x, in this case, is 10. Still have to subtract 6. 2 times 10 is what? 20. Then we subtract the 6. What is 20 minus 6? Go down. 19, 18, 17, 16, 15, 14. You get an answer of 14 there. All right, so 14 goes here. Finally, we have 2 times whatever x is equal to, 12, minus 6. Now, 2 times 12 is what? 24. And then we have to subtract 6. Now, if you count backwards, you're going to get to, when you subtract 6, you'll get 18. And so 18 goes here. So all of that work, all of this stuff was just applying the rule. Y is equal to 2 times x minus 6. And now we have the numbers to plot. So we have 4, 2. Let me check. 2, 6, 10, 14, 18. X is 4, y is 2. X, don't forget, is this direction, and y, don't forget, is this direction. X is 4, y is 2. That means there's a point right here because it was 4, 2. Here we have 6, 6. X is 6 and y is 6. X is 6 and y is also 6. That means there's a point right here. Next, 8, 10. X is 8, y is 10. X is 8, y is 2, 4, 6, 8, 10, which means it's right there. Next, we have 10, 14. X is 10, y is 14. X is 10, y is, where's 14? Right there, right? So a dot goes right here. 12, 8. X is 18, sorry, 12, 18. X is 12, y is 18. You go all the way up to 18, which is right here because it reads 18. And then we can try and see what something like this looks like. It appears to be a line to me. We'll find out in just a second. Let's try to line them all up and see what we can do. And I think we can connect right through the center of all of these dots. So that does appear to form a line. And we talked in the last lesson what these graphs can represent. This might be, time ticking. X could be the time ticking, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. And this could be the temperature of, of a room. Or this could be the distance up an elevator is going. So this could be how high an elevator is going, and this could be how many seconds it's taking. So you can see the elevator is going up and up and up. So just a couple of examples there. Let's take this one down and do the next one. All right, here's our next problem. Again, we're given the x values, and we don't know the y values because they have a rule. We have to calculate y, which is equal to 0 times x plus 7. So if you're going to write that down, you would say that y is equal to 0 times x. That means 0 times x. But then after that, we have to add 7. So just put the plus 7. So y values are equal to whatever x is times 0. And then after we do that, we just add 7 to it. So let's see if we can figure this out. Whatever x is equal to, we have to multiply 0 times x. But we know x is 0. And then we add 7. Now, what is 0 times 0? It's just 0. And then we have to add 7 to it. So the answer is just 7. So actually 7 goes right there. All right, next, let's take a look. 0 times x, x is 3. So 0 times 3, then we have to still add 7 to it. But again, 0 times 3 is 0. We take a 0, we add 7, we still get 7. All right, what else is next? Let's say we have, for the next point, 0 times x plus 7. So we have 0 times x is 5 plus 7. But this again makes 0 plus 7 is 7. I think you can see the pattern. They're all going to be 7 because this is 0 times x plus 7. But this is 0 plus 7, again, 7. The exact same thing is going to happen. 0 times 10 plus 7 is going to be 7. This makes 0, and then you have the 7. So all of these are 7s. It's kind of weird. Let's take a look and see what the graph of this thing would actually look like. So x is 0, y is 7. X is 0, y is 7. Remember, the x direction is this direction. The y direction is this direction. So x is 0. That means you don't even go that way at all. But y is 7. 1, 2, 3, 4, 5, 6, 7. That means there's a dot right here. 3, 7. X is 3, y is 7. X is 3, y is 7. That means there's a dot right here. X is 5, y is 7. X is 5, y is 7. That means there's a dot right there. Looks like a straight line. 8, 7. X is 8, y is 7. Again, still looks like a straight line. X is 10, y is 7. X is 10, y is 7. So again, this looks to me like, and it is in fact, a straight line. So let's just take a look at that real quick. Put them up there, just double check, and it looks like this thing goes through all of these points. Now, this line is different than the other lines because it's not slanted. It's actually completely flat. So what you see is that flat lines like that have all of the same y values. And that makes sense because y is telling you how up or down you're going. But if y is always the same number, then no matter where you go in this direction along x, y is always the same number. So it's just flat like this. So what would this represent? Just as an example, let's say this is time. Time in this direction, and then this is representing the temperature of a room, 7 degrees. Okay, next second goes by, still 7 degrees. Next second goes by, still 7 degrees. A few more seconds go by to here, 5 seconds in, still 7 degrees. 8 seconds in, still 7 degrees. 10 seconds in, still 7 degrees. The temperature doesn't change. If you have a flat line and you're talking about something happening over time, nothing is changing. The temperature is still 7 degrees the whole time that we look at it. That's what something like that might actually mean. All right, for the next problem, we have, again, the x values given to us. We do not know the y values. We have to calculate it. The rule is y is equal to 2 times x minus 10. So in terms of math, y would be equal to 2 times x minus 10. Whatever x is, we multiply by 2. Then after we do that, we subtract 10. So let's go do it. Let's take a look at this. The rule is 2 times x minus 10. So for this line, it would be 2 times x, which we know is 5, minus 10. But 2 times 5 is 10. We still have to subtract 10. What do we get? 0. So the y value here is just 0. All right, take a look at the next one. 2 times x minus 10. 2 times x, but we know that is 7 minus 10. 2 times 7 is 14. Still have to subtract that 10. What's 14 minus 10? It's 4. And we get an answer of 4. Rule, 2 times x minus 10. 2 times x is 8 minus 10. But 2 times 8 is 16. Now what is 16 minus 10? You get 6. And a 6 goes right here. The rule is 2 times x minus 10. 2 times x is 9 minus 10. But 2 times 9 is 18. And what do you get? 8. Like this. And then for our final point, the rule is 2 times x minus 10. X is 10 minus 10. What is 2 times 10? That's 20. And 20 minus 10 is 10. So the answer is 10 here. And 8, I forgot to write it down, is right there. So we have 0, 4, let me just double check myself, 0, 4, 6, 8, 10. All right, so now we have the points. Let's see if we can plot them. 5, 0, x is 5, y is 0. Of course, this is the x direction, that's the y direction. X is 5, y is 0. That means it doesn't go up at all. So we have a dot right there. 7, 4, x is 7, y is 4. X is 7, y is 1, 2, 3, 4. Means there's a dot right there. 8, 6. That means x is 8, y is 6. X is 8, y is 1, 2, 3, 4, 5, 6. Means there's a dot right there. X is 9, y is 8. So x is 9, and then y goes all the way up to 8, which is right here. All right, so we have a dot right there. The final point is 10, 10. That means x is 10 and y is also 10, which means there's a dot right there. And I think you can see it, obviously, but we're going to just kind of double check. We can see if we can get a line to go through all of those. In this case, we can, so we just connect the dots. And we have a line there. So what could this represent? It could be lots of things. You know, we've talked about distance along a stick and the temperature going up, or it could be after, this could be time, and this distance here, this direction here could be the distance an elevator goes up, or the distance a climber climbs a mountain. So he doesn't do much of anything until 5 seconds. He's still at the ground here at the bottom at 0 meters. But then as the time goes on, then maybe he climbs up to 4 meters. And as time goes on again, he gets up to 6 meters. And time goes on again, he gets up to 8 meters. Time goes up again, he goes up to 10 meters. So this could be the distance a climber is climbing up a mountain every second or every minute or whatever it is in terms of time. All right, this next problem, we're given the x values, and the rule is that y is equal to x plus 3. So in terms of math, the y values are going to be equal to whatever x is, just add 3 more. So this one, we probably don't even need to write it down too much. All we need to do is take the x values and add 3. So here we have 0 plus 3, and that's equal to 3. And here we'll have 3 plus 3, because it's just x plus 3. 3 plus 3 is 6. So we don't have to keep writing down. We can just add 3. 4 plus 3 is what? 7. 6 plus 3 is what? 9. And 7 plus 3 is what? 10. All right, so now we have the points. We can plot them on the graph. 0, 3. X is 0, y is 3. Again, the x direction is this way, and the y direction is this way. X is 0. That means I don't go at all this way, but y is 3. That means I go up 3. All right? 3, 6. X is 3. Y is 6. That means y is 6. It goes up like this. 4, 7. X is 4, y is 7. X is 4, y is 7. That's right there. All right, next we have x is 6, y is 9. X is 6, y is 9. That's right there. And then we have 7, 10. X is 7, and then y is 10, all the way at the top, like this. And of course, we can draw this. This looks like a straight line as well. So we can put it through all of these dots and just see what happens. And of course, it's a straight line as well. So we've talked many times about what this could represent. Obviously, whatever's happening is going up over time, if this is time, or up over distance, if this is distance. There's other ways that we could represent it as well. All right, here is our last problem. We're given the x values. We need to calculate the y values. The rule is that y is equal to x multiplied with itself. So that doesn't mean x times 2 or x times 3. It means x times itself, means x times x. That's when you multiply something times itself. So in terms of math, you would say that y is equal to x multiplied by itself would be x times x. That looks a little weird the first time you look at it, but I promise you it's not that bad. So here, what is x? It's 0. We need to figure out what 0 is multiplied by itself. 0 times 0 is 0. There you go, 0. This one is x multiplied by itself. 1 times 1. What is 1 times 1? It's just 1. Here we have x multiplied by itself. 2 times 2. What is 2 times 2? That's 4. Here we have x is 3 multiplied by itself. 3 times 3. What is 3 times 3? 9. And finally, what is here? 4 multiplied by itself. 4 times itself. 4 times 4 is 16. So here we have the table of values. Multiplying something by itself is not that big of a deal. It's actually easier than some of the other ones. So let's go and plot the points. We have 0, 0. That means x is 0, y is 0, and that's going to be way down here because it doesn't move any direction. 1, 1. X is 1, and y is also 1. So far, it looks like we could have a line there. 2, 4. X is 2, y is 4. X is 2, y is 1, 2, 3, 4, which is right there. And then 3, 9. X is 3, y is 9. X is 3, y is way up here at 9, like this. All right, and then finally, 4, 16. X is 4, y is 16. X is 4, going up 16. Now we've hit 10, and then we have something off the board. Notice we have a note here. 1 point will not fit on the graph. So 4, 16, if we drew a graph where we had 16 lines going up, then we would be way up here. So it's way up off the board here. So I'm not going to draw that last point, but you get the idea. This thing is not a straight line. It's called a parabola, actually. It's a very important shape in math, and it's going through something like this, and you can see how it's just going to keep going up, 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 because here at 4, it's going to be 16 points up in the y direction. So it goes way, way, way high. All right? And actually, this shape of a parabola has, it's called a parabola, this shape that does something like this. It's got lots and lots and lots of important uses in math. When you throw a ball and it goes up and it goes down, that shape that it makes is an upside down one of these things, right? So we actually learn and use these shapes in math all the time, but we don't really think about them. But when you throw a baseball, that perfect arc is an upside down version of one of these things. We'll learn about that later. So here we have conquered the idea of graphing ordered pairs, but we actually had to apply a rule to calculate the y values first. And you might say that the y values, or the y variable, is what we call it, is dependent on the x values. So because it's dependent on it, because the only way we can get them is to calculate it. These guys, or what's given to us, these numbers are dependent on this because we get them from calculating these guys. So dependent numbers, dependent variables are something we're going to learn about a lot more later. So I'd like you to practice these yourself. Calculate the values and then plot them, and then follow me on to the next lesson. We'll continue building your skills step by step. Learn anything at mathandscience.com.